Okay, good morning again, grade 9. The continuation of the operations on rational expression goes with addition and subtraction of rational expressions class. Why did I started with multiplication and division and not addition? It's probably because the end result of the solution to subtracting and adding rational expressions uses the concept of multiplication of rational expressions. It also is going to use the concept of simplifying rational expressions. That is why we need to understand first simplifying of rational expressions and multiplication of rational expressions for us to understand fully addition and subtraction of rational expressions. There are two steps in simplifying rational expressions upon adding and subtracting. It's simply first step there is get the LCD. Then the next step, combine like terms. No? Perform the indicated operation. Whatever the operation needed in the problem, then perform it. So let's try examples for us to understand addition and subtraction of rational expressions fully. So we have here the definition of an LCD. LCD, by the way, is literal in its definition, no? The least value common to both denominators. Something like that, no? If you have a denominator and you have a set of factors from that set denominator, the least common of these values will be your LCD. However, if you look at it in some terminology, you can also associate the LCD to LCM. Finding the LCD means finding the LCM. Okay? So let's have this fractions class. 3/4 plus 2/3. You're going to have the LCD, which is 12. No? So to find the LCD, which is 12, you just have to either multiply the denominator or list the factors of 12, or the list the factors of 4, which is 4, 8, 12, 16. And if you go with the factors of 3, you have 3, 6, 9, 12, 15, 18, 21. So from the mentioned values, the common between these factors of 4 and 3 is 12, and that's the least of the common. Huh? We can have the common, which is 24, no? Another common to 4 and 3, which is 24. But lesser than 24 is 12. And then the solution goes with 12 divided by 4. We have here 12 divided by 4 is 3. 3 times 3 gets 9. 12 divided by 3 is 4. 4 times 2 is 8. This is very elementary to you, no? So let's try to proceed then. So collect the numerators. Right now, we have the same denominator. So what is the rule in adding fractions with the same denominator? Just simply copy the numerator, or rather copy the denominator, which is 12, and then combine the numerator. Whatever the whatever the operation in between the two fractions, if this is subtraction, so this will be 9 minus 8. If this is addition, we have 9 plus 8, then you copy the denominator, which is 12, so you'll get the answer, 17 over 12. Huh? Never mind with this one. So we have this common. So directly add 3 and 1, you'll get 4. Then copy the denominator, which is 5. Here, the LCD or the LCM is 6. So perform the operation. 6 divided by 3 is 2. Times 2 is 4. 6 divided by 2 is 3. Times 1 is 3. Then subtract. You'll get 4 minus 3 is 1. Copy 6. And then this one is division. So what will you do? Multiply the numerator by the reciprocal of the denominator. So what is 1/2? That is now 1/2 times 4/3. We have this in our division of rational expressions, right? So multiply the numerator and then reciprocate the denominator, or reciprocate your divisor to get the solution. And then multiply. 1 times 4 is 4. 2 times 3 is 6. And after that, reduce 4 over 6. By dividing 4 and 6 by 2, you'll get 2/3. That's simple subtraction and addition of fractions. But if these fractions involve is a fraction of a polynomial, then what will we do then? So here are the steps in adding and subtracting rational expressions. If you can factor, factor. If you can cancel the common factors, applying multiplication of rational expressions, then cancel these factors. Then look at the denominator, get the LCD of your denominator, if possible, reduce it, and then perform the indicated operation. My steps a while ago is just simply these ones capsulated into two. Find the LCD, then perform the indicated operation. So here is reminder class. If the denominators are the same, directly add or multiply, or rather directly add or subtract the numerators if they have a common denominator. If the denominators are different, that's the time you're going to find the LCD. Okay? So, questions regarding the rules? Probably we will have to see the rules with ourselves there now. So we have here example number 1. 2 over 3x plus 5 over 2x. They don't have the same denominator, so the LCD there is 6x. If you're going to solve the value, then we have here from the given, which is 2x, 2 over 3x and 5 over 2x, we just simply do the, I don't know what's the term to this one, but if you simplify 2 over 2, it's just simply multiplying this fraction by 1. I know na, this is what we call as multiplicative identity. No? You just have to multiply the value with an identity which is equal to 1. No? To arrive at the LCD, which is 6x. Similarly, to arrive at the LCD of your second term to 6x, so the 2 will be multiplied by 3. And the numerator will eventually be multiplied by 3. Ergo, you're going to have the value now 4 over 6x and 15 over 6x. Or if you wish to check it, if this is really 4, since the LCD is 6x, so we have 6x divided by 3x is 2. 2 times 2 is 4. 6x divided by 2x is 3. 3 times 5 is 15. Okay? And then you can now add the numerator, which is 4 and 15. So that would be 19 over 6x. Question? Probably it would be easy. It is easier for a monomial denominator. It will then be harder if your denominator is a binomial. Worst, it will be a trinomial, no? But the idea of factoring should always be your sanctuary in this lesson class. So again, if you do have questions, feel free to unmute yourselves and then ask the said question. Now to proceed, we have here example B. 3x all over x minus 4 plus 6 over x minus 4. You do have a common denominator. So what will we do then? We have to copy the denominator and directly add the numerator. 3x plus 6. And since 3x plus 6 can be combined, you'll end up with the answer 3x plus 6 all over x minus 4. Or if you can factor, please factor. Like in the numerator, you can get the common, which is 3, leaving x plus 2 as the factor of 3x plus 6. Then the denominator is x minus 4. Sir, is it possible if the answer ends up only with 3x plus 6 all over x minus 4? Yes, indeed, the answer is just the same. But if you can manage to factor the terminologies, leave it as factors. In our lesson right now, it's best for you to end up your final answer as factors. Maybe you can find common values there that you can eliminate upon factoring. Okay, let's have here this one. Simplify the difference between 3 over x plus 2 and x over x 8 over x minus 2. Do we have this? Do you have a similar denominator? The denominator of the first term fraction is x plus 2, but the denominator of the second term fraction is the conjugate of the first term, which is x minus 2. Therefore, we don't have the same denominator. The idea here, class, in finding the LCD of two polynomials is simply copying whatever the polynomial that is not common between the two terms being added or being subtracted. In short, the LCD here is x plus 2 and x minus 2. Okay? So if you look at it, it's just simply combining the two denominators as one, having as our LCM. A big no-no for you to multiply para later if you can have factors that can be found in the numerator which is similar to the denominator, then we can just directly add it. So we have this solution then. The solution goes with replacing your denominators with the LCD, or you can do this solution class. The same as what we did a while ago. Okay? So since the LCD is x plus 2 and x minus 2, and we already have the x plus 2 here, so we just have to combine it with the x minus 2. And whatever we multiply to our numerator will have the same value to be multiplied in our denominator. Much like the same with rationalizing denominators, right? But since this is not radical, so we cannot term it as rationalizing denominators. Instead, we multiply it we multiply our fraction by an identity. And then here, class, the LCD is supposed to be x plus 2, x minus 2, and you already have the binomial x minus 2, so you're left with the value to be multiplied as x plus 2. And similar to the numerator, you'll multiply the same value. Simplify, then we have this expression. So we have the denominator, which is now common, but the numerator is being simplified by the product of 3 and x minus 2 and 8 by x plus 2. So 3 times x is 3x, 3 times negative 2 is negative 6, 8 times x is 8x, 8 times 2 is 16. Do not forget your operation is subtraction. Please bear in mind that if you subtract binomials, there's something that you need to do to the subtrahend. No? So what will be that something then? This one. You need to place the subtrahend with as parentheses. Why? Because you are subtracting the whole value of your x minus x, 8x and 16. If you will not place the parentheses class, 8x is the only negative value. 16 will stay positive. Now take note, this is supposed to be applicable to both your 8x and your 16 as a subtrahend. Then just simply copy the minuend and then copy the denominator. Perform the indicated operation. You have 3x minus 8x is negative 5 and negative 6 minus 16 is negative 22. So our final answer is negative 5x minus 22 all over x plus 2, x minus 2. Or you can factor the negative sign class. You can factor the negative sign in your numerator. You'll end up with the answer negative quantity 5x plus 22. No? The question regarding this example. So feel free to unmute yourselves if you do have a question. Let's proceed then. You are done copying. Catherine, you're done copying? Okay, so let's proceed then. We have here another example class. So we have x plus 3 and x minus 1. X plus 1 is your denominator. So our LCD here would be x plus 3 and x minus 1, or rather x plus 1. Why do I have to keep saying x minus 1? So the operation is addition, so no need to worry with the parentheses. So our solution then will end up with this one. 2 times x plus 1 and 3 times x plus 3. Or we can also follow the same class. This value class here, for a while before, this is the denominator. We can also do the other solution we had in the simple fraction. X plus 3 times x plus 1 divided by x plus 3 is x plus 1 times 2, so you'll get 2 times x plus 1. Okay? And then this expression divided by x plus 1 is x plus 3 times 3, so you'll have this one, 3 times x plus 3. Okay? Or in our previous solution, we can do it in this way. Since the denominator or the LCD is x plus 3 and x plus 1, so the numerator and the denominator of the first term will be multiplied by x plus 1 and x plus 1, ending up with this expression, right? And then the second fraction, since our LCD is x plus 3, x minus 1, and we already have x plus 1 here, so we just have to multiply it by x plus 3, both numerator and denominator. That's why you have here the expression. Get it? It's just being combined directly. You can do that in your solution paper and then eventually leading you to the same solution as this one. Get it? If you follow the previous solution then. And then applying the rules in domain, the domains in our answer would be all values of x except -1 and -3. Salin na natin yan kasi from time to time, you'll have to always consider what are the values of your domain. Simplify. 2 times x is 2x, 2 times 1 is 2, 3 times x is 3x, 3 times 3 is 9. Combine like terms, 2x plus 3x is 5, 9 plus 2 is 11. And then copy the denominator. Okay? So let's proceed with another example then. We have here quite a difficult example class because our denominators are actually trinomial and a binomial. But then again, it would be easy for you guys to add or subtract if you express your trinomial and your binomial into factors. So let's first factor the denominator class. The denominator's factor would end up with, for x squared plus 6x plus 9, the factors will be x plus 3, x plus 3. For the difference of two squares, x squared minus 9, the factors will be the conjugates, x plus 3, x minus 3. So what will be our LCD? Meron dito na wala dito, meron dito na wala dito. The LCD then would be the 2x plus 3 and 1x minus 1, or x minus 3. Okay? You can expand this as x plus 3, x plus 3. Please don't be confused. So the 2x plus 3 and 1x minus 3. If that's the case, then we can combine these two. You'll have x plus 3 squared. And since this is the LCD, so we multiply both numerator and denominator by x minus 3. Okay? However, this solution class, if you are going to look at this solution, this part here, that one, that actually is from the value 1 over x plus 3, and x minus 3. And since in the problem, you have 2x plus 3 as our denominator, so we multiply both numerator and denominator by x plus 3. Okay? So this is where we get to have the value x plus 3, and combine the 2x plus 3, you'll get x plus 3 squared. Don't be confused. It's just that in this solution, we ended up with combining the two x plus 3 as the square of a binomial. So let's continue. So copy the denominator since they are now the same, and then the numerator, you just have to copy it as well. But of course, the operation that you need to perform first is multiplication of x plus 1 and x minus 3. After that, you subtract the whole value of x plus 3. See, this is subtraction. So place the binomial x plus 3 inside the parentheses. And then multiply x plus 3 and x minus 1, or rather x plus 1 and x minus 3, you'll get x squared minus 3x plus x minus 3. So this is what we are going to do here, class. X times x, x squared. X times negative 3, negative 3x. 1 times x is 1x or x. 1 times negative 3 is negative 3. Negative x, negative 1 times x is negative x. Negative 1 or negative times 3 is negative 3. Get it? Just have to perform the indicated operation as I mentioned in the previous text. So that solution ends up with 3 terms containing the same variable x and two terms containing the idea of it being constant. So what will we do is we combine like terms, and combining like terms we end up with x squared minus 3x minus 6. You cannot simplify this class because I think x squared minus 3x minus 6 is already a prime trinomial. No? You cannot get the factors to end up with a negative 3x as a linear expression. So this is already your final answer. So this is a prime trinomial. Question? Please copy. Okay, can we move on to the next slide? Okay, so let's have this one. How about you try it before I solve it, Beth? You try. We had this before in our example, so I think you can manage to answer that one. Do you have an answer? I think the others are still bowing, so you are still solving. I think Al is already done since Al is not bowing the head. So would you like to share your answer, Al? Unmute yourself, Albert. And I wish to hear your answer, Al.
Negative x times x minus 7 over x minus 1 times x plus 2.
What's the numerator again? I know that the denominator is correct, but what was the numerator again?
Negative x times x minus 7.
So negative x, quantity x minus 7.
Yes.
And then the denominator goes with the denominator here. So let's try to see if the answer is right. And that is indeed correct, class. Negative x, quantity x plus 7, or in this expression, I did not factor the negative x, no? I always remind you guys to factor, and I myself did not factor it. So probably the factors here would be negative x, quantity x, minus 7. Which is indeed the same answer as the answer of Al Nicolas Laura. So if you do have the same answer with Al, can you check it, class? Wait, I still have to answer the call. Okay, so we are done copying the solution. So I think we still have another example here. This one. I am going to ask a girl to share the answer of this item. Copy. Should I share the factors of the denominator? These are the factors of the denominators. Sige, para you can continue your solution then. Magdako atong problema ka Terenda. Kandin siya anay mo 500 eh. Bugat ang ulo, no? Okay, you just have to look at it, class. This is the factors of the denominators. So, you look at these factors nga the first terms contain which is not found in the second term. Or put it this way. Naa dire nga wala dire. These values, look at here, compare to the values of the subtrahend's denominator. Find these terms that is not located on each of the factors. And eventually, that will be the multiplier of both numerator and denominator. Tayo this one. The denominator of the first term is x plus 3, x plus 2. And then the denominator of the second fraction is x plus 3, x minus 1. So we have here an x minus 1, which is not located in the first terms. So we multiply these two by x minus 1. In the same way as you look at the denominator of your second fraction, we only have x plus 3 and x minus 1, but we don't have x plus 2. Therefore, the x plus 2 will be multiplied here with our second term because our LCD is this one. Our LCD is x plus 3, x plus 2, x plus 1. It's like collecting terms which is found in, which is common to the factors of your denominator. And then upon multiplying these with the numerator and denominator, you'll end up with the answer already. So I think your answer will end up with the denominator x plus 3, x plus 2, x minus 1, right? So may I ask, what is your numerator, Bem? Bem, would you like to share your answer, Bem?
X times x minus 7, sir.
X times x minus 7. Show us with the answer of Asia, x times x minus 7. And let's see if the answer of Asia and Bem are correct. So we have here the solution plan. So we have the denominator. This expression multiplied by this expression is x plus 1, our x minus 1, times 3x. So we have 3x times x minus 1. This expression divided by this expression is x plus 2. So we have 2x times x plus 2. Simplify the numerator, you'll get 3x squared minus 3x minus 2x squared minus 4x. Combine 3x squared and negative 2x, you'll get x squared. And then negative 3x and negative 4x, you'll get 7x, negative 7x rather. So if you factor it, you'll get x quantity x minus 7. which is the answer of Bem and what's the other name? Asia. Thank you, Bem, and thank you, Asia. So, double check if your answers are correct, yes. Catherine, do we have the same answer, Catherine? Nakuha ba natin? Nakuha natin? Nawala si Catherine, ah. Hindi ko na nakita si Catherine. Ayun si Catherine, nakita ko na. Hi, Catherine, do we have the same answer? Good. Give me a thumbs up if you have the same answer with Pam and Asia. Harl is also the same. Ken as well. Much like I wish to know the answers of the others, I cannot see all the frames here. Al and Chelsea does have the same answer. Thank you. So we'll have probably this is the last. Last study class. I'll give you the factors then of the denominator. So we have x plus 3, x minus 3, x minus 2, and x minus 2, x minus 2 for the second term. So your LCD there would be the 2x minus 2s and 1x minus 3. Okay, you continue.
We do not like the natural ability to fly, that's not in us. We cannot breathe underwater without using breathing apparatus. We cannot survive in certain environments like other animals. These are just a few of the limitations of human beings. However, these limitations did not totally define us. We have used our intellect to devise means to achieve several feats. This ability to surpass limits is called transcendent.
If you do have an answer already, so simply type your numerator class in the chat box. No? Whoever gets to have the correct answer first, or whoever gets the answer first, you type your answers in the chat box and we'll see if your answers are correct. No need to type the denominator because obviously the denominator is this one, x minus 3, x minus 2, and x minus 2. However, of course, if there are values that can be cancelled, the denominator will change. But I just wish to know the numerator. We have one chat already from Ken Robertson. Ken Robertson's numerator is x quantity 9x minus 23. Same with Ken Buliser, x quantity 9x minus 23.
Our mind invents an important tool that allows us to go beyond many of our physical limits. Although we have these physical limitations, we can transcend them because of our spiritual dimension. And we also have our inclinations that allow us to surpass these limitations. These are felt bodily functions like hunger.
I'll do have the same answer with Ken and Kent. Your name, Ken and Kent, are tongue twister to be known. I can sometimes pronounce Ken as Kin and Kent as Ken. Then we have Kent Barcenelia as well. Kent, Ken, Kin.
Each individual carries within himself the possibility of transcending his limits by exerting effort and perseverance.
Anyone else who wishes to share the answers?
Tell you that you should exercise effort and you should persevere more. So those who are, I don't know if some of you.
How about Harl? You type your answer, Harl.
I'm just not sure if this is familiar.
You done typing your answer? Bem also has the same answer. Catherine, you type your answer. Chelsea, you type your answer, Chelsea. Those who are done solving, you please type your answer. I just wish to know if, even if you copy the answer of Harl or whoever here, I just wish to know if you solve it on your own. Especially those that are, that the cameras are turned off, so I cannot see for sure if you're solving. Those cameras which are turned on, I can attest that they're solving since I can see their hair. in their camera. Gana sila sa kanong. I can see their head in the camera. No? If I'm going to zoom in, probably I can see some community in your hair. No? Are there community in your hair? No, sir. It's already an ecosystem, sir. In my head, sir. It's already an ecosystem. Okay, Ken, Marcinelia is negative x squared minus 7x. So at least we have a different answer from Ken. I'm not so sure if whoever gets the correct answer this time, okay? Chelsea has the same answer with Harl and the rest. Same as Asia, no? They have the same answer. It's just that in the answer of Chelsea, it was not factored out. So let's see if the answer of Harl is, the answer of Kent Marcinelia is the only correct answer amongst the others, no? So let's try this one. What will we do? Multiply the numerator by the denominator's result after dividing. So x minus 2, x minus 3, x minus 2 divided by this expression is x minus 2 multiplied to the numerator, blah, 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 blah. And the answer is 9x squared minus 23x. And then the denominator is this and that. So Spencer is correct. Rafael is correct. Probably there's something wrong in the solution of Kent Marcinelia that makes it wrong. Kent, you try to copy the, ano Ken? Try to copy the solution, Ken.
Opening yourself to new experiences and ideas is another aspect of transcendence. Being open.
I think we still have one more. Can we still do one more? 9:22. I'll just post na lang the solution, class. So this is the solution to this problem.
If you stick to
Copy na lang.
who you are
Oh.
just there and then, without opening yourself to the possibility that you can do more.
So if you look at it, class, here,
you have not transcended.
be careful with the binomials, especially if it is a subtraction sentence. You have to consider
that you are
that
beyond
what
you
do you call that? You have to consider that the sign will be distributed to the terms in the inside of the parentheses. Yes, Bam, do you have a question, Bam?
Be open to the
wala.
possibility that you can go and reach point B.
For those who are still confused, please share your questions. Raise your concerns so that we can deliberate it and probably find a solution to it. Man, I wish to see your faces, so I'll stop the sharing. Is it fine? You're done copying the solution here. Probably you can practice this one. You need not to copy the solution. For as long as your target numerator is 4x minus 2 or 2 quantity 2x plus minus 1.
What I'd like you to do is
Okay?
you answer it.
So can I see the frame of each one of you guys? And this is the sad part here. Only the first 2 layers are online and the rest of the layers are offline. Hi Ken. Hi Chelsea. Ayun, I can see the faces of Ken and Chelsea. Rafael is, happy birthday Rafael. Al, happy birthday Al. Okay, so questions class, before we end the call. Clarifications that you wish to ask so that we can answer it here. Am I heard there, Corinne and Natalia? Spencer, turn on your camera, Spencer. What is that, Spencer? Oy? If you don't have a concern, we can end this call already.